I'd like to also thank Madam for the excellent presentation. My name is M.cherif. My thesis is about securing access to patient data based on biometric technology with the supervision of Dr. M.cherif. Today we'll start by taking a look at the background concepts, then we explore the problematic. We'll see our first proposed solution and its amelioration, as well as see the challenges that we face and finish by final thoughts. So, to start, what is the goal of this thesis? Our goal is to develop a protocol or a framework that uses biometric features to secure our authorized access to patient medical data. While securing access, we also want to enhance and optimize the efficiency. So we'll take a look at some concepts. IoT revolutionized the healthcare industry by facilitating remote monitoring for patients and also emergency diagnosis for these chronic diseases. So, as the use of IoT evolved and its implementation became even deeper in the healthcare sector, a new technology or definition surfaced, which is Internet of Medical Things. This refers to interconnected medical devices that enable us to remotely monitor patients for the diagnostics and monitoring. So what are biometrics? As we all know, they are identifiable traits or features, as we can also say, or even behavioral characteristics that can be used to secure authentication. So, our problematic. Firstly, why even secure the patient data? As we know, due to the sensitive nature of this data, we must secure the access control. So the access must be controlled, as well as help in protecting the privacy of our patients and also prevent tampering of this sensitive data. Our proposed solution is to use biometric features to secure this data, communication, and improve the efficiency by reducing the computational complexity. But despite advancements in this field, and despite advancements in the field of biometrics, we still have challenges when applying it to edge devices. For this end, we propose to use federated learning as a solution. Federated learning is a decentralized learning approach that trains an algorithm using edge devices. These edge devices have local models for each client, and these edge devices collect and use the data, the private data of the client or patient in this case, to actually help to improve its local model. So to train its local model, in other words, sorry. And the global server then takes the weights of the local models and applies them to the global model. So the data now is only accessible to the edge devices. There is no centralized data collection mechanism. So the solution became now to implement federated learning with IoT devices to enhance biometric recognition. So in order to do this, we can use features or traits such as ECG signals that we capture from the edge device itself, and or gait dynamics, which is the manner in which a person walks. So it can be captured using accelerometers or any other type of, even cameras. It can capture how a person walks. And also activity patterns can be unique to each person. So a person can walk and sit differently than another person. As you can see, these, especially activity pattern, these traits are not really practical to use only on their own, so we propose to combine them in a multimodal system, to fuse them, to improve accuracy, and especially to ensure the robustness of this framework. So what are the main challenges that we encounter? As always, data scarcity presents itself as the main challenge. And for federated learning, real-world experimentation is still lacking. Hardware implementation costs is for us to experiment is really a challenge in and of its own, as well as the algorithmic complexity when applying federated learning, and we also have to comply with privacy and regulatory healthcare data rules or regulations. So in conclusion, addressing the challenges that we talked about previously will pave the way for a robust, hopefully robust system that secures access to healthcare or patient data. We hope that the fusion of biometrics with federated learning will enhance this security while improving the optimization and also help to protect the privacy of the patients. That is all, and thank you very much. If you have any questions.
I don't have question, but we are, for all the audience, we are in the big data world. And all students have the limitation of the data set. Donc c'est une idée. Je comprends rien. On a dans le monde de big data, mais tout le monde a le monde de données. C'est vraiment incompréhensible. Donc c'est une question, c'est juste un commentaire.
Thank you.
Yes. So you want to propose a multimodal approach using different types of biometrics.
Yes.
So was this approach proposed before, or?
Yes. So people already use multimodal systems for biometrics and fused different biometric traits to establish more robust and accurate systems. But our contribution will be to use this. As well as implement it using federated learning, because that has not been done before.
So when implementing, so your contribution will be adding federated learning to this multimodal approach.
Yes, and also proposing perhaps a multimodal system that hasn't been proposed before. That is also a possibility.
Okay.
Yes. Thank you. Yes.
First, thank you for your presentation. You mentioned in the presentation in the page, I don't remember the number, but you was like talking about the way how a person walks.
Yes.
And
it can be unique and used in your study.
Yes.
In this case, how do you handle if a person? I think everyone can have this. You wake up and you are feeling not good and you're not walking right this day. What happens?
So anomalizing the system. This is why exactly we proposed the multimodal system to in case, as you can see, anomalies do happen, especially with gait and activity patterns as well, because these behaviors that can change, you know. And for this, we proposed the multimodal system to use maybe ECG to be more confident in recognizing people. Yeah.
So which model?
Multimodal, yes. Yes.
So as you talked about the multimodal systems,
Yeah.
what are the modalities that you are going to use during your federated learning?
So right now for my review paper, I'm actually exploring human activity recognition with federated learning, and I hope to find gaps that I can explore, maybe improve even the federated architecture for human activity recognition or HAR systems. Mainly we want to combine this the activity recognition side with probably ECG or any other biometric things.
ECG and other?
No, human activity recognition and other
No, my question is, what are the modalities? Exactly. You talked about ECG.
Yes.
So you're gonna work about ECG modality and others.
I did not fix the modalities because I have to still explore the possibility to combine them, because we have to keep in mind that edge devices can be constricting, especially in resources and sensors. Yes, I would like to answer. Thank you.
You have these edge devices?
No, no, that's
Yes,
why
yes.
Still,
Yes, we have it.
yes.
Visitation.
So I think it will be a bit difficult to collect data about the three biometrics you mentioned. So is there any data set you are going to use, or are you planning to generate the data set yourself?
There is also a possibility to generate the data set ourselves.
So there isn't any prepared data set for...
Well, there are datasets already, but if you are making a new multimodal system, that automatically means you have to make your own dataset. Yes, because these features have to be combined.
Yeah. Of a single person.
Of a single person, exactly. Any other questions? Yes, sir.
For me, I have two questions. The first one is the context in which you want to develop this research. Because you are trying to look at federated learning, so you must have some kind of local processing.
Yes.
And then you have some global processing. So you have your local models and then you have your global models. So what would be the local processes in this context? So are they going to be local hospitals, or is it going to be just a simulation to work?
No. So for us, the environment we proposed would be for patient monitoring in homes. So maybe elderly patients, or even in hospitals as well. For the biometric recognition, yes, it can be, for example, used with any edge device, such as we can see smartwatches right now. So for our experimentation, we'll use a Raspberry Pi, but we hope to propose the framework itself. Just for simulation, we will use the Raspberry Pi.
It's different because if you are working at the individual level,
Yes.
then you don't need federated learning, because it's one person sending his or her information to somewhere, let's say a hospital or general practitioner care of doctor specialist. So you don't need federated learning there. You talk about federated learning when you have many entities or local entities where you don't want to share the details of your patients with other entities. So this is why you do local processing and you define local models, and then you send the parameters of your models to the global model, and then you try to learn from the different local models. So I think you probably need some clarity in here on whether it's individuals that you are working with, or if they are entities that you are looking with.
So you mean, are there entities such as hospitals,
Yes,
for example?
so this is where figurative learning is used. So when you have entities and you don't want to share the data of your patients with other entities, so this is where figurative learning works better. If it's only one patient sending his or her information, then I don't see figurative learning to be honest with you being used here. And then the second question is, where is the security issue? Are you trying to protect the transmission of the data during the transmission?
Yes.
Or are you trying to secure the data once it reaches the endpoint where the data is going to be processed?
So for us, we will focus on the transmission itself. So during the transmission of this data, for example, when a patient visits a hospital, doctor, excuse me, for a visitation, it can be then used to recuperate his data from, to authorize the access to his personal data. So his records, medical records, or his sensitive medical data. That is the goal of the thesis. And for your first question, it is a good question. Actually, we will have to clarify that. Yes,
this is what I have noticed for me when I listened to your talk. Yes. I didn't see the clarity in what you are trying to do. And in addition to clarity, then we are going to come back to the same question of the scientific contribution of your work. Yes. So you have to be clear about this, because application of federated learning to health problems is very well known these days, but within a very specific context. Yeah. If you go to, let's say, developed countries, you have many general practitioners that will probably link with local hospitals, or you have many hospitals within one region that do not want to share the data of their patients with other hospitals. So this is where federated learning is used. But from what you are explaining, it seems that you are trying to solve a transmission problem here. So you are securing the transmission of the data from patients.
Yes, we still haven't really clarified the end goal. For now, we still are lenient, and we have an idea, but the implementation depends on the result of the review and the work we're doing currently with the human activity recognition. So after that, we will consider our options and make it hopefully more clear. Thank you. No other questions? Okay, I want to thank you all for attending today, and hopefully we can have more discussions.
Merci à tout le monde. Donc, on va prendre une pause café pendant 1 minute. Ensuite, on va revenir pour la suite du programme. Merci.